Hello everyone and welcome back to Functional PHP 7. In this section we're going to be learning about function evaluation strategies. In this section you're going to learn about three fundamental techniques all related to functions. The idea of lazy versus eager evaluation, a technique known as partial function application that then leads to the basics of function currying. Let's begin with the first video titled Lazy versus Eager Evaluation. Because PHP is not a natively functional language, functions are executed immediately regardless of whether the result is needed or not. In other words, PHP only supports eager evaluation, and that means that a function gets executed as soon as it's seen by the interpreter. On the other hand, functional languages like Scala and Haskell support lazy evaluation by default. That's just the inherent mode of executing functions. And so functions are executed only when the result is needed. However, using higher order functions, we can emulate this idea of deferred or lazy execution. And whenever we run into some issues, particularly with processing collections, we can always resort to iterators and generators in PHP to kind of emulate the idea of evaluating collections or infinite collections lazily. Let's jump right into the code. In the previous section, we took a look at a function called generate email, which would take a user object and a random integer. Now, whether that user object was needed or not, this entire function or this entire composition of functions always ran because PHP is running functions eagerly. Now suppose that this function random integer was something a little bit more complex and it actually produced an exception or some invalid number that we were checking against. Suppose we had an if-else statement inside of generate email that would check against this random number, and if it's out of bounds or if it's negative or zero, we wouldn't generate the email at all. We would just, return back an error. Regardless, the user object was still generated and this entire code still ran. Let's take a look at another example. Suppose I have a function called multiply with or multiply by. And what this function does, we'll get rid of this code. And what this function does is it takes an integer, just to keep things simple. But what it's going to do is going to return back a callable. So let's go back to that use of higher order functions that we learned about in previous sections. The function that's going to return back is going to take another integer, and finally this will return back the int. So in other words, the result of the multiplication. The inner functions uses a, so we bring a into the inner functions closure, and then finally we compute the multiplication of a times b. So why we would do something like this, and why not directly multiply a and b and just accept both parameters? Well, because deferring evaluation has a lot of benefits. I can always make an assertion that a function make even, I can make this function, I can create this function by doing multiply by 2. So multiply by 2 is a function that runs, that returns a callable, and that callable goes into make even. So make even is a function created from another function. Now this function hasn't run. This function the function pointer is stored lazily into make even. And in fact, because multiply by is pure, then we can say that multiply by 2 represents a pure number, a pure representation of all the even numbers. In fact, I can go ahead and assert that 4 would equal make even of 2. This assertion would always work because make even 2 is a pure representation of the number 4. In other words, we say that a pure function is a lazy evaluated number, is a lazily evaluated value or collection of values. Now what can I do with make even? Because I have a variable function stored in make even that's lazy, it's a function that's dormant and it's waiting to be executed, I can always do some very nice things. So suppose I want to map make even, and notice that even though PHP is eagerly evaluated, this function is not executed yet until the expression is executed, and then I want to map that function over a simple collection. So let's see what happens when we run that. And as you can see, I was able to successfully map the function make even over the array 1, 2, 3, 4, 5, effectively getting 2, 4, 6, 8, and 10 in a completely new array. Hopefully that example shows you the benefits that we can get with lazy evaluated functions. But that's not the end of the story. Consider this example. We'll use the PHP function range to create an array of elements 1 through 5. And when I run this basically prints out this array. And what I want to do is say this function doesn't exist and we'll create it. But what we want to do is basically take a slice of that. So we're going to go ahead and take from this source array, we're going to take 2 elements. And when we execute this, we expect to return just 1 and 2. So we've basically taken the first 2 elements. And so because PHP runs eagerly, the range function will run to completion to satisfy this variable, right? Even if I were to embed this function in here directly, and then apply array take. And if we were to implement this function, we could use array slice to do this. So array take is a function that takes an array as input and the amount of elements to extract, returning back another array, of course. And this function is just basically taking a slice of that array from 0 offset to that amount. So that's essentially what array take looks like. And so what would happen when we do something like this? So this would work, and this would print out elements 1 and 2. But what happens when we do something like this? We create a huge array using range of all the elements from 1 to PHP's max integer number. And then we take 2 elements from that huge array. So this actually wouldn't work, because what would happen is that because PHP's functions are eagerly evaluated, the range function, let's say that I would embed it in here, the range function would like to run first until completion before array take gets a chance to run. So what this is going to do is completely exceed the stack. It's going to blow off the stack when trying to create an array of such an enormous size. In a lazily evaluated language, the result of the range function would be used only when required. And so even though we would execute a function to create a range from 1 to infinity, infinitely many elements, we would only take 2 of them. And so the resulting array would actually be an array of 1, 2. And in a functional language, this would actually work. Well, we can actually make this work by using some PHP 7 features. In particular, we're going to be using this feature called a generator. A generator is essentially behind the scenes an iterator object. And so we can use it to lazily process or iterate over infinite amounts of data. So the way we're going to do it is we're going to first refactor the range function, and then we're going to refactor the array take function. Let's begin with the function range. So we'll call it xRange, so that not to have it confused with PHP's own range function, but the interface is going to be very similar. It's going to have a start value, the end value, and this optional step value that indicates how the array values would accumulate. But instead of returning an array, this function would actually be returning our iterator or generator object. Generators in PHP are very well designed to work with for each loops. So even though that's not the preferred construct to use in functional languages, it's something that we need to do just to make use of, to do the best practices of what PHP puts in place. So our range function can run a for loop that starts at the start value, it increments all the way to the end value, and here's where the power is. Instead of returning the functions, we're actually going to yield a value of I times the step. The step indicates how it accumulates. The yield function indicates or signals to the PHP interpreter that this is actually a generator function. So what it's going to do is that it's going to do a reentrant function. In other words, the yield pauses the state of the generator where it is. It pauses the state of all the variables so that you can always come back to it. When the generator function is invoked again, it remembers the state of all the variables that were in it, and it can recreate that and yield the next value. Array take needs to be refactored to take advantage of this generator. So array take, instead of working over an array object, is going to work over a generator, which we'll call the source. And of course, we'll need to know the amount of elements to take from this generator. And the output is an array of just the elements including up to the amount. Again, generators are designed very well to work with for each. So we'll start with that. And then for each value in the source, we will create a temporary function and store those values in there. And if would go all the way up to when we've picked up or collected the right amount of values, and at that point we can break this logic. At the end, we return the result. So the generator function behind the scenes is really acting as an iterator. Putting it inside of the for each loop treats it as an iterator behind the scenes. It's invoking the next method on the iterator and giving back all the elements in that source generator. And now I can make this work just like the other example. So what I want to do is array take of the xRange from 1 to PHP int max, and we're only interested in the first couple of elements. And so now instead of running eagerly and taking up all the space in the PHP interpreter runtime, it's actually going to just take the first two elements. The generator will run up until where it needs to and not further than that, according to our logic and array take, and only return the first couple of elements, or we can take the first 2, 3, 4, or 5 elements. Let's see how this code runs. Voila, and this is actually the result we expected. And here's one last example to kind of drive this point home. Because lazy evaluation is not just a matter of convenience or a means of iterating over infinite amounts of data. We can also use it as an optimization. So consider this refactored version of range, and we called it drange for a deferred range. And it has the same front-facing API with the start, end, and step, but instead of returning at the generator directly, I'm returning a callable. And so when you see that a function has this return type, you can pretty much understand that this is a function that is deferring some kind of computation. Okay, so now it's returning a callable, and the callable is what actually runs the body of code. But as is right now, if you call drange with all the parameters, it just kind of sits there and wait. I'm also going to be using this function average, and this just basically does the sum of all the elements in an array. This is completely eager, divided by the count, and it returns the average from an array of numbers. Now, if I were to write a function that compares the average, it kind of does an assertion, and I would use the average of the range of numbers from 0 to 10 and run that computation, then this function would run eagerly, right? It would first run the range function and then use that to run the average function and then pass it on to run the compare average and make sure that those two numbers match. But what happens if I pass a null or something else here? Why would I ever need to run all of this stuff to then later throw it away? So we can actually create a compare average function that uses lazy evaluation as an optimization. And what it takes, instead of using the array directly, it's going to use the callable that led to the generator. So this would be an array generator. And it's going to use that other number similar to what we passed before as the comparison value. So we're going to compare that running this average compares to that value that we pass in. And if it does, it returns true. Otherwise, it returns false. So this is really nice because, see, I can do all of my upfront logic and check. If the comparison is less than 0, throw an exception. Otherwise, run the average function with all the data contained in the generator. So, with returning a range of 0 to 10, this is probably not a big deal. But if you wanted to take the range of 0 to PHP int max, or some other long-running computation, then this would be a very big deal. That you would just do, run all this, compute all this data to then just throw it away. So after the comparison is true, remember this array generator here object, this object is still dormant. It hasn't actually produced any values yet. So I'm using this nice PHP iterator to array object. This basically does all that for loop, just like we did before, and converts the generator function into an array, takes the average of that, and then compares to that comparison. So the final result, when we compare average to using the drange of from 0 to 10, compare that to 5.0, that assertion is actually true. And we can test that by running mean, and there you go. The fact that the exception didn't fire means that the comparison was successful.